At the peak of a high-dose psychedelic experience, the phenomenological boundary between the observer and the environment vanishes. The deeply felt sense of being a continuous, isolated I slowly diffuses into a much larger, interconnected system. Awareness continues, but the brain processes experience without assigning it an owner. This represents a structural shift in neural organization. The sense of I is a continuous pattern of neural connection that can be chemically dismantled and measured. A sudden localized shutdown in the brain's central self hubs triggers a massive system-wide surge in global connectivity. We can trace this process from the initial quantification of the experience to the mapping of its biological footprint and finally to its clinical application. Translating ego dissolution from the language of mysticism into the metrics of neuroscience provides the essential framework for modern psychiatry. For decades, the inherent subjectivity of losing oneself made it an untouchable target for rigorous scientific study. In 2016, researchers at Imperial College London established a method to turn this ephemeral state into a quantifiable metric. They developed the Ego-Dissolution Inventory, a standardized scale that converts subjective reports into clinical data. This metric was validated across a massive dataset of over 1,800 reported drug experiences, proving its statistical reliability across different substances and doses. This data visualization plots those 1,800 experiences, revealing a clear linear trend. The reported intensity of the drug scales directly with the dissolution scores. The analysis isolated ego dissolution as a single coherent factor, mathematically distinct from generic intoxication or sensory hallucinations. With the state turned into a reliable number, the hunt for its physical location in the brain could finally begin. The search centers on the default mode network, or DMN, the brain's self-modeling machinery that integrates autobiographical memory and internal self-narration. The sense of self emerges from a dynamic pattern of connection between specific cortical hubs. In 2012, researchers used functional magnetic resonance imaging to observe the brain's acute reaction to psychedelics for the first time. They administered psilocybin, expecting to record a surge of neural activity. Instead, this 3D model highlights a sharp drop in blood flow localized in the DMN hubs. When key hubs like the parahippocampal and retrosplenial cortices decouple, the network's integrity falls. The intensity of ego dissolution scales precisely with this network breakdown. Lebedev's 2015 findings confirmed that the loss of overall network integrity is the primary biological driver of the experience. The brain's self-network must be quieted in order for the subjective experience of the self to vanish. If the self-network is suppressed, why doesn't the brain simply lose awareness? Tagliazucchi's 2016 mapping study investigated the global whole-brain response to this localized DMN shutdown. They found that a modular, segregated brain architecture suddenly shifts into a dense, uniformly interconnected web, as normally separated association cortices begin communicating intensely. This map overlays the surged functional connectivity directly onto a heat map of 5-HT2A receptors in the cortex. The anatomical alignment is precise. The brain merges with itself exactly where the drug molecule binds to the system. Ego dissolution is a reorganization, where the self-model relaxes its grip and the brain briefly functions as a single hyper-connected whole. Explaining the therapeutic logic behind this temporary neurological reorganization requires a specific computational framework. Researchers developed the relaxed beliefs under psychedelics, or REBUS model, to explain this mechanism. The default mode network normally enforces our priors, rigid, top-down beliefs that filter reality, including entrenched self-conceptions like "I am worthless." This schematic illustrates a thick, dominant top-down arrow representing a rigid prior, which suppresses the weaker bottom-up arrows of raw sensory data. Under the influence of the psychedelic, the top-down arrow thins, allowing bottom-up sensory data to flow freely. The drug reduces the precision or confidence of these high-level filters, temporarily unclenching an over-certain self-model. Psychiatric disorders like depression and OCD are characterized by cognitive rigidity. They require a dissolution of the self-model to allow those fixed beliefs to be revised. In clinical trials for treatment-resistant depression, patients who report the highest levels of ego dissolution show the most significant reductions in symptoms weeks or months later. This direct correlation makes the depth of the peak experience a primary predictor of therapeutic success. By setting down the entrenched story of the self, the brain gains a temporary window to reorganize its internal narrative. However, the mind often interprets the sudden loss of high-level filters as literal biological death. Without a psychological anchor to hold onto, this rapid transition can violently spiral into a state of acute, overwhelming distress. The same biological event that heals in a controlled clinical container can cause significant harm in a chaotic or unprepared setting. Clinical preparation, or set and setting, is the essential framework that turns this biological disruption into a durable therapeutic outcome. Researchers can now measure the dissolution, locate the DMN shutdown driving it, and observe the rare window for neurological reorganization it provides. Ego-dissolution is a major neurological opportunity. When held within a safe container, it provides the precise mechanism required for lasting psychological change.